we'll see who else comes and joins us. To those of you that are here, it's really awesome to have you here. So thank you for joining us. We've been talking about differentiation, and last time we had a look at some sort of slightly more difficult examples. So we spoke about what would happen if we had one term, and then if we had numerous terms, what we would do if we had brackets, what we would do if we had radicals, what we would do if we had divide lines. These were some of the questions that I wanted us to finish the last time that we never really kind of got to. So that would be I, K, and M. I don't know if you want me to do, or if you want to try one of them, or if you want me to run through it quickly. We can talk about that now, but the ones that I sort of really wanted us to go and have a look at were these scary guys over here. All right, so these are the three most difficult ones that I could find in the textbook. And then I've also gone and collected a whole lot of past exam paper questions so that you guys can have a look at that. So at this stage, I really want to know where you're at. Do you want to try some of the easier ones, or should we just jump straight into the more difficult ones? How are you guys feeling? Do you want the challenge, or do you want the easy ones? You can just put what you're up for in the chat. Where do you want to start? Okay, Michelle says easier ones. Yeah, absolutely. If you want to unmute and say what you'd like, that's also absolutely fine. Okay, so you're also saying let's warm up first. All right, that's absolutely fine, not a problem. So these are still not straightforward questions. These are still quite difficult. The other ones are just very, very, very difficult. Do you want me to do one, or do you guys sort of want to jump in? There's a difference between I, K, and M. K and M have got a binomial denominator. I has a monomial denominator. So how we would deal with that would be a little bit different. Are you guys happy to try? Give it a bash. Okay, cool. All right. So I'll let you pick one and you go for it. Okay. And then Nicole and I will just be quiet. If you need any help, then just ask us. We're right here. Okay. Good luck. Neo, it's up to you. If you want to do more than one, you're welcome to. I mean, I can work through all of them with you afterwards. If you want to try all of them, it's up to you. Okay, cool. Chiamo, how many did you do? Oh, wow. Okay. Are you guys ready for me to start going through them? Do you want a little bit more time? Okay, good, Tisha. Did you also do all three, Tisha? Wow, that's wonderful. Well done. Okay, so what I'm going to do in the meantime, just as you guys are obviously finishing up, you're obviously quiet because you're concentrating. I'm just going to start putting the solutions up. And then, yeah, I'm sure by the time I'm finished, you guys will be done as well. Okay. All right, so for those of you that are finished, let's just get rid of this thing over here. Oh, hang on a second. Okay, did you guys get the same answer for question I? I've just done it in purple. Cool. Okay, Cassandra, that's nice. Okay, I'm doing the next one in this sort of plum color. Okay, so for question K, I got 2 as an answer. And then let's do M quickly. So what I would do with the numerator here, sorry, you're quite right. It is minus 5/6, not 7/6. Yes, yes, yes. Sorry, quite right. Because you're taking away 1, 100%. Okay. Yes, Neo. Good job. Okay, then what I would do with question M is I would probably, I mean, you can factorize the cubic if you want to, but I think what I'd probably do is do it by grouping. So if we do x cubed minus 2x squared and we group those two together, minus x, that would be minus 2, and then that's all over x plus 1. Okay, which gives us dx there. Then here, if we take out an x squared, that gives us x minus 2 minus x minus 2 all over x plus 1, which then gives us, just move this up a little bit. Now we can take out x minus 2, that leaves us with x squared minus 1 over x plus 1, which then leaves us with x minus 2 times x plus 1 times x minus 1 all over x plus 1. That's going to cancel, and now we need to remove those brackets, so that would give us dx x squared minus 3x plus 2, and now we can finally differentiate. That would give us 2x minus 3. Do you guys agree? Did you get the same answer? 2x minus 3? Question M? Cool, Chiamo, well done. How's everybody else doing? Does it make sense what I've just done? Is there anything that I need to explain? Yeah, sure, Michelle, no problem. Is that far up enough? Anybody got any questions? Are we all good? Okay, so I'm going to move on then. Since nobody said that they've got any questions or anything, of course, if you do, then please do interrupt me and I'm more than happy to scroll back up again. So now that we've got ourselves warmed up, let's go and have a look at these ones over here. These ones are really difficult, like really, really, really difficult. Obviously, BB would be the most difficult one that there is here. So if you'd like, you can more than welcome to try all 3. If you can do these, then you know that you can differentiate. So again, I'm happy to be quiet and let you guys work through these, and Nicole and I are here for you if you've got any questions. Okay, let me just move that down a little bit. Okay, there you go, should be big enough. Give that a try, Matrix. Michelle, which question are you talking about? Oh, do you mean, okay, now hang on a second, Michelle, you can't take the 2 up to the numerator. So you want to separate the numerator from the coefficient. So in the case over here, I know which one you're talking about. Let me just highlight it for you. This one here, Michelle. So how you want to write that is you want to write it as 1/2 is the coefficient, x to the power of -3. Okay, like that. That's how you've got to write it. Does that make sense? So it's just the variable that needs to go to the numerator. The 1/2 is the coefficient. Pleasure. Okay, just let us know when you're done. Or if anybody's struggling, please let me know and I'm more than happy to help, obviously. Yes, Johannes, with pleasure. I know that is a very, very difficult one. So yes, I will do that. With you guys. Okay, so Gwadi, are you finding Z difficult? Yeah, the trick is actually not to remove the cube root first, Johannes. The trick is to simplify what is inside the root first, and then work with it. But I'm going to show you how you would do that. Yeah, you do get stuck if you remove the root first, the cube root first, which you obviously wouldn't know when you first start doing this question. It's one of those that you kind of have to play around with and then get stuck and try again and try something different. Fortunately, things like that don't seem to be too common in exams, but as I say, these are proper difficult extension questions. Okay, so Gwadi, where did you get stuck with Z? I'm going to start slowly. Okay. All right, that's fine, Sagwadi. I don't want you to sit there and feel stuck and not know how to do this. Okay, so what I'm going to do is I'm going to, like with the other ones, I'm just going to work through from top to bottom. So Sagwadi, we're going to get to Z right now. I'm just going to do X first. Okay, so if you are stuck, then yeah, I'll work all of them through with you. Okay, so with a question like X, I think it's probably easier to separate the coefficient from the variable and move the variable to the numerator first. And then you want to get rid of the radical and you want to get rid of the brackets. Okay, so no problem, Boyd Shepherd, welcome. We were just trying to work through these questions. These are some sort of difficult challenge questions that I've given the class to do. We warmed up on some easier stuff, but these are the really difficult ones. I'm just going to work through each one and explain how we would do it. Okay, so the derivative with respect to X of, okay, so what I'm going to do is I'm going to bring this factor that's at the end, I'm going to bring it to the front, and I'm also going to write root X as X to the power of 1 over 2. Then as far as what's inside the bracket is concerned, X cubed can just stay exactly as it is. And I'm going to pull the half off, and then we're going to write X to the power of -3. Okay, everybody happy with that? Okay, next step. Keeping my notation because I'm not differentiating just yet. I'm still preparing my statement for differentiation. And now you're basically working on a grade 8 concept here where you're multiplying by distribution. So when you multiply like bases, you add your exponents. So X to the power of 1/2 times X cubed is going to be X to the power of 3 plus 1/2. So that would give us 3.5 or 7 over 2. And then I'm going to multiply my X with my second term. So 1 times 1/2 is 1/2. And when I multiply like bases, I keep my base and I add my exponents. So now -3 plus 1/2 is going to give me -2.5. So that's going to give me -5 over 2 if my fractions, I haven't made a mistake. All right, now I'm ready to differentiate. I can see my coefficient, I can see my variable in the numerator, I can clearly see what my exponents are. So now I'm ready to apply my power rules. So I'm going to drop my d over dx, I'm going to drop my square brackets, and I'm just going to write equals. And I'm going to end up with 7 over 2 times 1, so that's 7 over 2x, and I'm going to take 1 away. So 7 over 2 minus 2 over 2 leaves me with 5 over 2. And then with my next term, a negative times a positive is a negative. And 5 over 2 times 1 over 2 is going to leave me with 5 over 4. Write down my x, and again, I need to take 1 away. So I'm going to subtract 2 over 2, so that leaves me with -7 over 2 as my exponent. Okay, how did that go, those of you that did x? Did you get the same answer as me?
Yes, ma'am.
Yes, okay, can you see the well done? All good. Okay, lovely. All right, let's move on to the next one, and then we can do that monster at the end. Okay, so question Z now, matrix. So they want us to find the derivative of S with respect to T, and they've told us that S equals. Okay, so now we need to get rid of radicals. So that's going to give us 3t to the power of 5 over 2 plus 2t to the power of 3 over 2. And what I'm going to do is I'm going to split it up at the same time and get rid of the radicals. So I'm going to put 3t at the bottom, and that's to the power of 5 over 2. See, squashing it in there a little bit, which is not great, over 3t to the power of 5 over 2. Okay, so what I've done there is I have got rid of my divide lines, I've got rid of my radicals, and I've split it up all in one go. So the first term of S is 3t to the power of 5 over 3t to the power of 5. So we know that anything divided by itself is 1 plus, and again, I'm going to remove the coefficient, so 2 over 3. And when I divide like bases, I keep my base and I subtract my exponents. So 3 over 2 minus 5 over 2 is negative 2 over 2. Okay, so that's going to leave me with negative 1. Everybody happy with that? Okay, and now when I differentiate S with respect to t, so S with respect to t, I'm going to end up with 0 because 1 would become 0. Negative 1 times positive 2 over 3, that would give me negative 2 over 3 t to the power of negative 2. How did that go? Sagwadi, I know you said that you struggled with this one. Does that make sense to you? Okay. Any other questions before I start on the monster? Okay, how's this going so far? You guys getting these right? Oh, good. Oh, good. Okay. All right. That's lovely. Well done. Because as I said, these are good. Well done. These are very difficult. So if you can do these, if not, it's just silly mistakes. Okay, Johannes. All right. So yeah, rather you make those silly mistakes now and learn from them rather than in the exams. Okay. All right. Well done, guys. I'm so pleased that you were willing to try these. And even if you do get them wrong, we know that it's not the end of the world. We can go ahead and go and fix it. All right. So let me get on with this monster. I'm going to move the question over a little bit like that so that I don't have to rub out what I've already written. Although I might need to go down onto some clean paper. All right, let's get rid of that. Okay, so what you guys mustn't be afraid to do is don't be afraid to play with questions. You know, if you do something and you get it wrong the first time round, don't look at it like it's the end of the world and that you're never going to be able to do it. It's basically like trying to find your way through a maze. And sometimes we take a turn and we end up getting stuck. And what we need to do is retrace our steps and think things through again and try something else, maybe try something that we haven't done before. It's exactly the same with this question. If you try and get rid of the cube root first, you end up getting stuck. So what you have to do is add the fractions together first, but I'm going to show you now what I mean by that. Okay, so keeping our notation, our dx, giving ourselves plenty of space to write here. Ooh, okay, so the cube root of, so now x to the power of minus 1, we would write as 1 over x, okay, plus 2, all over x cubed plus 2x to the power of 4, okay. Let's just, oopsie daisy, now if I do that, this whole thing's going to disappear. I'm just going to make it a little bit smaller. Okay, so that would be our first step. Our second step would be to say that in the numerator, okay, so I'm highlighting the numerator in yellow, we are adding fractions. When we add fractions, we need a lowest common denominator. So that's going to be my next step. So I'm going to keep my dx, I'm going to keep my square brackets, I'm going to keep this horrible cube root, and now I want a lowest common denominator. Okay, so my lowest common denominator in this case matrix is going to be x. At the top here, I've got 1 plus, this is 2 over 1. So if I need to multiply the bottom by x, I must multiply the top by x as well. So this is going to leave me with 2x over x. All right. All over x cubed plus 2x to the power of 4. And that I'm going to factorize. Is everybody happy with that? Can you see that okay? Is it big enough?
Ma'am, can you please re-explain last?
That's fine. So what I've done in my second step here, Kanisile, is I've found a lowest common denominator because in the numerator, I'm adding fractions.
Okay, ma'am.
So when I'm adding 1 over x to 2, 2 means 2 over 1. So I've times that by x and I've times that by x. And that's how I've got 1 plus 2x over x in my numerator. Does that make sense?
Yes, ma'am. Okay.
All right. You happy with that?
Yes, ma'am.
Okay, lovely. All right. Now what I'm going to do, and I could have done it at the same time, but I didn't. Now what I'm going to do is I'm going to factorize the denominator. Okay, so I'm keeping the numerator the same, matrix. Keeping the numerator the same. Okay, there's my huge, enormous cube root. Okay, so I've got 1 plus 2x all over x. All over, and I'm going to take out x cubed, and that's going to leave me with x. Sorry, I beg your pardon, not x. 1. So now hopefully you can start to see things taking shape here, matrix. It's going to leave me with 1 plus 2x. Does that make sense to everybody? Okay, so I've got a complex fraction. In the numerator, I have 1 plus 2x over x. And in the denominator, I factorized out x cubed, and I've got x cubed times 1 plus 2x in the denominator. Are we all good so far? Now, the next thing that I'm going to do is tip and times, because that's how I divide fractions. Okay, so I'm going to tip and times. So again, can you see I'm keeping my dx? I'm keeping my square brackets because I'm not ready to apply my power rule just yet. Okay, there's my cube root. Now I have 1 plus 2x over x. I'm changing the divide to a times. Okay, and remember what was here in my numerator, all of this stuff here that I'm highlighting in yellow, remember that was all over 1. So now when I multiplied, I'm going to put 1 into the numerator, and I'm going to put x cubed times 1 plus 2x in the denominator. Everybody happy with that? And now I can cancel something at the top with something at the bottom. Does that make sense to everybody? Are we all good so far? Any questions? All right, now again, I'm going to keep my dx, I'm going to keep my square brackets. I'm not ready to apply my power rule just yet. I've still got this nasty cube root, and this is 1 over x to the power of 4. Okay, now what I need to do is I need to remove my radical, and I need to take my x to the power of 4 to the numerator. Okay, so I'm going to write this as dx, and then here I'm going to write this as x to the power of negative 4 over 3. Does that make sense to everybody? Okay, so I have done a couple of things here. I've gotten rid of the radical, and I have written x to the power of 4 in the numerator and changed the sign of the exponent. Are we all happy with that? And now and only now am I ready to drop my dx and my square bracket and apply my power rule. Okay, so I'm dropping my dx, I'm dropping my square bracket, and I'm applying my power rule. So negative 4 over 3 times 1 is negative 4 over 3. Keep my x, and then of course I need to take 1 away. Okay, so 1 in the form of 3 over 3. So this would be minus 7 over 3 to the power of minus 7 over 3. And that matrix is how you would do that question. How do you feel? Have you followed? Is that okay? Yeah, crazy, hey, Cassandra. Michelle, yeah, that's a lot of marks. Look, generally in the CAP syllabus, we never ever see anything out of more than 7 marks for problem-solving questions. I would be very surprised if you got something like this. In exams. Okay, so don't cry just yet, Valerie. Oh, sorry, Johannes, was that completely overwhelming? Okay, don't panic, okay, is the first thing, okay? That is the most difficult question that I could find to give you, all right? So if that was difficult, it was supposed to be difficult. I want you to look at the exam questions though. All right, so it's nice for us to be exposed to these sorts of difficult questions in a safe space. Look at the exam questions, all right? So now these are things that I've gone and taken from past papers, all right? So the memos are here on the side. Look at this, okay? See, there's no need to cry, all right? So the first one is very, very, very straightforward. Can you see it's out of 3 marks? And there would be 3 marks on each of the 3 terms in your answers. Okay, even if you look at the second one, 9.22, that's not nearly as bad as the one that we've done. Okay, it's a pleasure, Cassandra. Absolute pleasure. If you want me to do it again, I'm more than happy to do that, but I just want you to be able to see things in context. Okay, so 9.2.1, everybody should be able to do that. 9.2.2, well, hopefully you guys would be able to do this as well because we've discussed all these things. All right, so what I'm going to do is I'm just going to be quiet for a little bit and I'll let you try. Now, let me just move this out the way. And that one as well. That one. Okay. Before we go on and do that, did this make sense to you? Is there anything here in question BB that you want me to go through again? Bearing in mind that this really is the absolute worst case scenario. Okay. All right, well, in that case, give these ones a bash matrix. Excuse me, sorry. Awesome. Well done, Johannes. Well done, Neo. Good. Yeah, these ones shouldn't be too bad. Cool, Oratile. Nice, Tisha. I'm just making these other ones a bit bigger. If you did want to try those in the meantime while you're waiting. Otherwise, I'm just going to work through the answers of the other two in a couple of minutes. Okay, Chiamo, you're also done. And Boyd Shepo. Yeah, nicely done, Matrix. Well done. Okay, so here we go. This is what you should have done in 9.2.1 and 9.2.2. 9.2.1, as I was saying earlier, would be the one where we would just expect we would get all our marks. That should have been quite easy for you guys. And again, I think it's nice for you to be able to see how it's going to be marked. So you could go straight into finding the derivative. So you can see there you would have 1 mark on 20x to the power of 4, another mark on negative 24x cubed, and another mark on 3. Okay, so hopefully we've all got 3 out of 3 for that. Here is 9.2.2. Let me just make this a little bit bigger for you guys so you can clearly see everything. And then again, you can see where the marks were allocated. Let me just move that one out the way. All right, so can you see Matrix again? They've spent some time preparing the statement, getting it ready to be differentiated before it actually was differentiated. So removing the radicals and also getting rid of the brackets. Does it make sense in the second line that they've got x to the power of negative x to the power of 1 over 3 over 2 plus x to the power of negative 2 over 9? Does that make sense? Do I need to explain anything there? Okay. And then in the third line here that I'm highlighting, all they're doing is in the third line, they are separating the coefficient from the base. And again, separating the coefficient from the base. Okay, so that they can apply their power rule. And then in this line over here, they've applied their power rule. So they've multiplied 1 over 3 with minus 1 over 2. That's where the minus 1 over 6 comes from. And then again, taken 1 away, and same story over here. Taken negative 2, multiplied it with positive 1 over 9, and that's where the minus 2 over 9 x to the power of negative 3. Can you see here, Matrix? Okay, so the marks are on these terms. So you don't have to write things with positive exponents. They did, but you really don't have to waste your time doing that. Just leave it and move on to the next one. Okay, does that make sense to everybody? Are there any questions? Cool, Johannes. I'm glad you're feeling okay. You're not crying anymore. How's everybody else? Okay. Cool, Valerie. All right. Do we need to do the poll tonight, Nicole?
No. Tonight it's not necessary.
No. All right. Okay, Matrix. That's our time up. Thank you so much for joining us. I hope this was useful to you. We've got one more lesson on this on Thursday, and then we're going to move on with our winter school program. Okay, so I hope you'll all still be here with us, and thank you for joining us this evening. Take care and enjoy your holiday.
Good job, Matrix. Bye.
Well done. Bye. Bye, Cassandra. Sure, Johannes, not a problem. Pleasure, Valerie. So there's question 8. And then I've got the answers on the side too, Johannes. It's a pleasure, Bochepo. If you want me to flash over those again.